These examples are all about solving equations with one step. In number 1, we have y plus 9 equals 4. Keep in mind we have to keep these equations balanced at all times. So whatever I do to one side of the equal sign, I must do to the other. This is now adding 9. The inverse is to subtract 9. So I would subtract 9 on both sides. A positive 9 and a negative 9 cancel, leaving me with y equals 4 minus 9, leaves me with a negative 5. There's my answer, because I have the variable by itself. Number 2 is only different because I currently am multiplying. To undo multiplication, I'm going to divide. So I will divide by 15 because I only want to move this 15. The b needs to stay on this side. I'll never move the variable in one-step equations. If I divide by 15 on the left, I divide by 15 on the right. 15 over 15 is 1b. I don't need the 1. Equals 60 divided by 15. That's 4. I have my answer. Number 3 are problems that some students struggle with. This is a fraction times a variable. To get that fraction by itself, or to get the variable by itself, I should say, I need to multiply, even though I'm multiplying now. The trick is I'm going to multiply by the reciprocal of my fraction. So instead of 3 over 4, it's going to be 4 over 3. If I do that on the left, I do the exact same thing on the right. That would give me 12 over 12, so it cancels. Leaves me with just the g on the left-hand side. Here, negative 3 times positive 4 is negative 12. Divide that by this positive 3. Negative 12 divided by positive 3 is negative 4. Variable is by itself. I have my answer. The difference between a problem like number 3 and number 4 is number 3 I have the fraction in front of the variable. Number 4 I have the variable in the numerator of my fraction. Keep in mind, we do not want to move this variable. So I do not want to multiply by 6 over h. I never want to move that variable in a one-step equation. So a problem like number 4, it's h divided by 6. I'm going to do the opposite and multiply by 6. But keep in mind, this is a negative sign. I want my variable to be positive here. So to get rid of that negative, I'm going to actually multiply by negative 6, because a negative 6 times a negative h over 6 is positive h. That's really negative 6 over 1. Those cancel. H over 1 is just h. And again, this is a negative 3 times a negative 6. That's positive 18. Be very careful with your signs. Number 5 is a different type of problem. It's technically a two-step problem, even though we haven't introduced that yet. I'm not going to add 2 to both sides, even though I'm subtracting here, because I'm not subtracting the 2. I need to look at the sign in front of the term I'm moving. The x is on the left, it's going to stay there. But this 2 is positive, so the only way to move it would be to subtract it on both sides. What we have to be careful of is that doesn't leave me with an x on the left. It leaves me with a negative x. And that's going to equal 10 minus 2, or positive 8. Back to our last unit, we discussed coefficients. The coefficient of this x is a negative 1. We want all of our coefficients to be a positive 1. So to get rid of my negative 1, it's negative 1 times x right now. I'm going to have to divide both sides by that negative 1. Now a negative divided by a negative is a positive. X equals 8 divided by negative 1 is a negative 8. Now my coefficient is a positive 1, just like in numbers 1 through 4. The last type that we see on our first homework assignment is double signs. Don't try to do too much work right away. Look and see if that simplifies first. Hopefully what we recognize is that if I have minus a negative, it's the same as plus a positive. So that's really z plus 7 equals 12. Now I can use my inverse operations. Subtract 7 on both sides of the equal sign, and we're left with z equals 5.